Hello friends. So today we are going to discuss about the distributed log tracing. So first, what is the distributed tracing and why it is basically needed? So whenever we are working with microservices where our application is having suppose tens or 15 or 20 or 100 microservices, and one of our requests is going through several microservices to return the final results. In this kind of scenario, we need to trace our logs. So when we are creating one request, then this request goes through the microservice 1, it creates some log in the microservice 1, then it is goes to then going to the microservice 2, it is creating some logs there, then again it is going to microservice 3, and so on. So when we are getting some results or when we are getting some logs, then we need to identify that whether all these logs, suppose we are getting 10 logs, so we need to identify that out of these 10 logs, which 3 or which 5 logs are related to a single request, or all these logs are related to different requests. So how we will identify, how can we group the logs based on the request, that okay, these 10 logs are belonging or related to one request, these 10 logs are related to another request. How we can segregate or we can bundle the logs among the use compile or use storage of the logs. So here comes the log tracing. So what is basically the log tracing? Log tracing is nothing but it's to identify the logs, all the logs of a particular request. These logs may be generated from one microservice, or these may be generated from the multiple microservices. So all these logs we can combine into a single group, and we can say that okay, these all logs are related to request 1, these other group 2 of logs are related to another request, that is the request 2. So for example, we can say here that request 1 is giving group 1 logs, and request 2 is giving group 2 logs, and these logs may be generated from one microservices or from multiple microservices depending upon the flow of this request. Okay, so here this group 1 logs, how these, suppose this is having say it is having 5 logs, so how can we say that these 5 logs are related to one request? So these we can say based on some unique id, some unique id, and this unique id is basically termed as the trace id. This is basically termed as the trace id. So for one request, one trace id will be generated, and this request is going through the multiple microservices. So this trace id will travel to each microservices, and each microservices will attach this trace id into their logs, and then based on this trace id we can group all these logs to a particular request. Okay, so similarly it will have unique id 1, similarly it will, this will have unique id 2, and that way we can segregate. So we understood that basically there remains a trace id, that is the unique id, and based on that we can group the logs, and those logs, group of logs belongs to a particular request. So how, then question arises, okay, how this trace id is generated and who generate this trace id? So we can generate it manually, but generating the trace id manually and managing it manually and instrumenting this trace id into the multiple microservices, it's a very tough task, and it will create burden over our development work. We need to consider over our business logic. We do not if we are investing much effort on these things, then our we will be we will not be able to focus on our business logic. So for that things, there are multiple uh, built-in tools are available, and we can use any one of those tools. Those are already well tested and well proven tools, we should use those. and one of those tool is OpenTelemetry. So this is basically used at the industry level for generating the stress ID and instrumenting into the requests that are going through the multiple microservices and gathering the metrics and spans. So again, what is the spans? So spans basically defines, so suppose if it is going through the microservice 1 and microservice 1 is calling the microservice 2 is calling the microservice 3, then spans basically defines that okay, what is the duration of the microservice 1. So microservice 1 spans under a span of microservice 1, the microservice 2 is triggered, and under the span of microservice 2 the microservice 3 is triggered. So this is basically the span. So these metrics, these stress IDs are collected or created by OpenTelemetry. So these we are creating through the OpenTelemetry, and this is industry standard. We can use it in any of our projects, and we can also use the Jaeger backend. So whatever the data OpenTelemetry is creating by instrumenting into these requests, these data OpenTelemetry doesn't keep it to itself. It generally exports those data, and then there should be someone who will gather these data, and then it will either save it in some storage or some file system, or it will show it to the developer so that a developer can go through it and can understand. So for that purpose we can use the Jaeger as a backend. So OpenTelemetry will create those data, and then it will uh, export those data to Jaeger, and then from Jaeger we can visualize it, or we can further process it. So for diagrammatic representation, I have created one very rough diagram here. It's not very industry standard, but I have just created a basic diagram so that we can understand. So here I have created three microservices, that is the order, payment, and user. And when client is sending the request, then order microservice is triggered, order microservice is calling the payment microservice, and payment microservice is calling the user microservice, and these three microservices can interact with the database. Now when the request is coming to the order, then order is generating some um, logs or some trace IDs. So these trace IDs are being generated by OpenTelemetry. So OpenTelemetry is basically instrumenting these requests. So OpenTelemetry is basically instrumenting this request. OpenTelemetry here instrumenting this request, and similarly OpenTelemetry is instrumenting this request also. And instrumenting means it is adding the trace ID. Trace ID means it is suppose if in first order microservice is being triggered, then OpenTelemetry has added one trace ID here, one trace ID here it has added in the request, then same request is going to the payment, then same trace ID is moving here, and same trace ID is moving here. So that's way same trace ID is being carried to the multiple microservices, and whatever the logs it is generating, in that log it is appending the trace ID and the span ID, so that as a developer when we will go through the logs we will be able to identify that okay, these five requests, these five logs are having the same trace ID, that means these are belonging to the same request. So similarly OpenTelemetry can instruments or can add trace ID in any request wherever we want, it can add. Okay, so here it can add. So and it is after instrumenting, it is gathering some data, like it is gathering the span ID, it is gathering the trace ID. So those data it is sending to the Jaeger. Jaeger is a backend, it is exporting those data to the Jaeger. Through Jaeger we can visualize it, and then um, whatever the logs these microservices are generating, those logs will have the trace ID, span ID, and those logs we can put into the ELK stack. ELK stack is basically a stack that is consisted of Elasticsearch, um, Lodash, and Kibana. So by using these three tools we create log visualization tool. So that is the another thing. Here I'm going to discuss about instrumenting the OpenTelemetry and showing it into the Jaeger. So for tech stack, if we see, so for tech stack, what we would need, we will need the Node.js, these three microservices, that is the order, payment and user microservice, and we need the OpenTelemetry and we need the Jaeger. So first, how we will get the Jaeger? To get the Jaeger, we will come here and we can download the Jaeger based on our operating system. And for Windows, we will get exe file jaeger.exe, and then that jaeger.exe, we can open our CMD, and from this CMD we can simply run that exe file. So we can simply here we can run this jaeger.exe, and then it will keep running, and don't close this CMD, just keep it open. And then we will write our code. So I have already created the code for saving our time. So let me walk you through the code. So here I have created the four um, services. One is the observability service. Here basically I am initializing the OpenTelemetry, and this service I am injecting in order, payment and user services. So for example, here let me first go through the observability service where I'm started these things. So if you come here, let me, yeah. So if you come here, this is the index under this I have created index.js, and here I have created this file, that is the start tracing. This is the main function for where I am initializing the telemetry and exporting the matrices. So here I have first created one exporter, and this exporter is exporting our traces means whatever the metrics it is creating. Our OpenTelemetry is creating whatever the metrics, it is being exported to this ID. This ID is basically related to Jaeger. We can create multiple number of the exporters, and we can send it to the different sources. Right now I have created one exporter and it is sending to the Jaeger. And after this we need to create node stack. We need to install the node SDK, and here under the node SDK we need to pass the service name. Service name is basically our service name. So as I told you that this start tracing, we need to call these services from this function from each of our microservices. So if we are calling from our microservice, we need to pass here the service name as a order. If we are calling it from payment, we need to pass it the payment microservice. So I will show you all these things. So here we are starting our node SDK, and we are saying that for which service we are starting this, and this is one that we are starting. Okay, so if I will show you here what we are doing, that our main purpose is to start tracing, that is the OpenTelemetry tracing. And here what we are doing, first we are identifying the service, that which service, for what service we are going to start this tracing, and then decide where to send the traces, means what is our destination. So this is our destination where we are sending this. Okay, and then enable the automatic tracing. So here we are enabling the auto instrumentations, and then start the telemetry engine. So here we are basically starting the telemetry engine. And few things, few function I have created. One middleware function I have created, and this middleware function, it is not doing much. It is what it is just doing that from traces, whatever the traces this OpenTelemetry is creating, from that traces it is basically getting the trace ID, that unique ID I have told you. So that unique ID, it is adding it here in the response setter, so that we will in the response we will get this trace ID. Basically this is optional, and in real time we shouldn't do this. I have done this just to show what trace ID we are getting in the response, but in real time project we should not do this. And third function I have created as a create logger. So in this I'm just I have basically initialized a Winston logger. Okay, And in this Winston logger, I am passing the service name, that for which service it is creating the logs. And then here if you see, the important part is that in each log I am adding the trace ID and a span ID. So this trace ID and a span ID basically defines that out of 10 logs, which 5 logs are related to one request and which logs are related to another request. Okay, and then these logs, if needed, we can send it to elk state, that is the elastic search plus lodes plus kibana, to visualize these logs and to for the observability purpose of these logs. Okay, so and here I am exporting all these three functions. Now let's see how I'm using these observability service in these three microservices, that is order, payment and user. So in order, I have created one index.js, and if you see in the package.json, I have installed it. So npm, I have just done npm install and given this file path, so it has installed it as a package. And then in index.js, we can simply use it like in the same way we are using the other packages. So it is a kind of internal package we have created. So here I have taken the observability, and from observability I have taken this create logger, I have taken the logger object, and from here I have started the tracing. And in both the cases I have passed the order service. And after these two code, I'm not doing anything related with the OpenTelemetry in this code. So OpenTelemetry will work by its own. We are not writing any code here related with OpenTelemetry, and we are just calling wherever log is needed. We are just calling logger.info or logger.error, whatever is required. We are doing this same thing I am doing in the payment service also. If you see here in the payment service, same thing I have done. These two lines I have added, and then here I am just adding the logging. No, not a single line of code has been written for OpenTelemetry apart from this observability service. Okay, apart from this, I have nowhere I have written any single line of code related with the OpenTelemetry. Okay, same thing is with the payment. Okay, now let's see how it is working. So to see this, I need to start all these three services, that is the order, payment and user microservices. So here if you see, I have already started these three services. Okay, and then I will trigger the order microservice, and order microservice is triggering the payment microservice is triggering the user microservice, and all these information will be captured, will be instrumented by the OpenTelemetry, and OpenTelemetry will export these matrices to the Jaeger, and then we will see in the Jaeger. So first I'm running it. So here I have triggered it, and I'm getting this response. So it is status is okay, and I've got this response. If you see here the response, under this I'm getting this trace ID. Okay, now to run the Jaeger, what we need to do, that this is the default URL of the Jaeger. So once you have run it in CMD and you have kept it open, then you can open the Jaeger UI like this, and then here you can search. So here I have the three services, so it is showing automatically showing the list of these three services. And for example, I'm searching it, then find the traces, and here it is giving the traces of last 1 hour. And if you see here in the last 1 hour, all these things are coming. For example, if you want to search, and here in the logs also, if you see in the logs also, it is adding the trace IDs. If you see here, it is adding the trace ID, and span ID it is adding. So based on the trace ID, we can identify that these services are belonging to the same one. For example, if you see so this 3C04, so this you will find here it is available in the this one is basically the payment. So similarly you will find the same 3C4 in the order, So this is basically the order, and same user also you will find. So you can identify that okay, these three logs are belonging to this one flow. And if we copy it and try to find in Jaeger, so let's come to Jaeger, and here if we are searching for this, press enter. So we are finding this information, and it is giving the complete trace ID. So if you see here, it is first giving that from here the span has started, and this is first span is being created from the order microservice, and order microservice has totally it has taken 97 milliseconds. And then from order microservice, it has called here the user microservice. uh, from user microservice, you can get the more information about user microservices here. All these informations you can get here. And if you want to compare, so you can compare between the two trace ID. So suppose if you are putting here if you are adding here one trace ID, and then you are adding here one trace ID, and if you are clicking on the compare, then it will give you the comparison of flow between the two microservices. So here, as the comparison of flows, as the flows are same for both the trace ID, so it has given the same flow. So these information it is giving. If you come here, it will give you, it has created one system architecture automatically based on the metrics it has received. So it has created a system architecture also. So these information you can get from the Jaeger. So these all today I thought to show you that how what is the distributed tracing, and how can we implement it through the OpenTelemetry and Jaeger. So Jaeger is basically showing these matrices. Jaeger is not for showing the logs. So one important difference is that Jaeger is not for showing the logs, it is just for showing the matrices, it is for showing the traces, it is for showing the span IDs, okay, spans. For visualizing or for analyzing the logs, so we will have to go to the Kibanas, and we will have to set up the Kibanas or Prometheus. Those things we will have to set up. But Jaeger is basically for matrices and spans evaluations. So this is all I am having today to discuss with my viewers. And if you like this video, then please share it with your friends, and please like my video and subscribe my channel. So thanks for being here.